this is initial velocity is 15, so I'm going to write 15 over here, and final velocity is negative 15. Why final velocity is negative 15? Because it lands exactly on the same height it starts from. Okay, so then my final velocity is negative 15. My initial velocity is 15. My velocity on the top is 0. That means this trip is 3 seconds long. 3 seconds long. So this velocity is the velocity at the top is 0. So in the top I have to have 0 right here. Right here. This velocity is 0. Okay. So the ball is moving up, slowing down because it's fired with acceleration due to gravity, slowing down. Velocity is 0. Speeding up, highest speed. Okay, this is exactly how we can do that. This is exactly how we can do that. Okay. The velocity is 15. So let's say velocity is 15. Slowing down. Velocity is 0. Increasing, and velocity is negative 15, and that's it. It touches the ground. Okay, now we're going to find area under the curve. Area under the curve. All right. So this is, let's first find this one. Displacement over here is equal to half BH. So displacement is half, B is 1.5 and H is negative 15. So displacement is 1.5, 15 and then 0.5, 11.25 meter. Don't forget the negative sign. And let's find this one. Displacement is half BH. So half B is 1.5 and H is 15. So this is positive 11.25. Positive 11.25 and negative 11.25. So displacement is equal to blue plus green. Blue is 11.25 and green is negative 11.25. So total displacement is 0. Wow. So I'm going to erase that. Now I'm going to write the total displacement, and total displacement here is 0. Total displacement here is 0. Okay. Now we have the final problem. All right, let's see. Okay, so say this is so let's say this is ground. Yeah, it's saying that, and this man, that there is a man standing on the rooftop of a building and throw the ball just like this with initial velocity 15 meter per second. So the ball, instead of stopping over here, which is the same height, instead of landing over here, which is the same height, the ball land on the ground, land on the road. This is a rooftop and this is the road. The ball land on the road. Tricky situation. The displacement should not be 0. Displacement is 0 over here because, as we said, the displacement 0 over here. So I know that displacement 0 over here, but here it's not 0. It should not be 0. So we need to draw the VT graph. VT graph gonna save us. So let's draw the VT graph. V and T. And it says that the total trip is 5 seconds. I know that this is 3 seconds here, 3 seconds, because this one is 3 seconds, because if initial velocity is 15, this must be 3 seconds, and this is 5 seconds. Okay. All right. So this problem is similar to this problem, except that this one, when I throw it, it comes to my hand. When I throw it, instead of comes to my hand, it slip my hand and fall on the road. Okay, which is not too bad. So initial velocity is 15, so I have to have initial velocity is 15. The final velocity, let's for a moment, let's think about this one final. Make the problem as easy as possible. 15 and negative 15. We're going to think about this part later. We're going to think about this part in a second. Okay? Let's first take care of that one, that easy. However, if the ball is in the air for 5 seconds, we know is velocity, right? Maybe I don't. Just to verify that, VI plus AT. So VI is 15, A is negative 10, and T is 35, right? So 35 is the velocity of the ball. The velocity of the ball is right here. The velocity of the ball is V final is negative 35. So I'm going to have negative 35 right here. Okay. All right. So velocity is 0 over here since this changed the direction. So velocity is 0 right here. Velocity is 0 right here. Okay. Velocity is 0 right here. All right. And velocity is negative 15 right here. Right here when the time is 3. Okay. All right, so let's draw the graph. Let's make it blue. Let's make it not blue, green, and let's make this one blue, because I just convert the blue part to VT. I did not convert the green part. Now I'm going to convert the green part. Before I convert the green part, I just want to remind you, these two must be 0. These two must be 0. Okay. Now I'm going to use the red. Let's make it red, a unique color. I'm going to go until right here. So it's going to be a diagonal line. Why it is diagonal line? Because this is still a curve. So a diagonal line. Okay. And this is 5 seconds. So I'm going to stop right here. Okay. So I don't need this reference anymore. So I can divide this one in two parts. This one is a rectangle, and this one is a triangle. Okay, now I think we can find the displacement. Lots of work. So now let's find the displacement right here. BH. B is 5 minus 3 is 2, and height is, let's say height is negative 15. Yeah, negative 15. So is how much? Is negative 30. I don't know. I don't know. Maybe I'm not sure. Okay, half, this one half BH, half B is still 2, 5 minus 3 2, and H is, I don't know, 35 and 15. 35 minus 15 is 20, but it's negative 20. 2 to cancel, so it's negative 20. So this one is negative 30, and this one is negative 20. So negative 20 and negative 30 is negative 50. So it's negative 50. So displacement is negative 50. How can I find distance over here? Don't know. So this is 11.25. This is negative 11.25. So now we have everything. So let's add them up. Create a space. So this is the blue, which is 11.25. Now this is green, and green would be negative 11.25. This is black, and black would be negative 30, and this is red. Red would be negative 20. If you take absolute value of them, all of them, the absolute value of this one is 11.25. Absolute value of this one is 11.25. Absolute value of this one is 30, and absolute value of this one is 20. So 50 plus 22.5, so 72.5. 72.5 is the distance. Lots of work. Hopefully you understood it. Thank you.